All right, so lesson 4.4, compare and order fractions. So building off of last time, we find the least common denominator. Once we found that, then we had to get equivalent fractions, and that's really going to build into what we're doing today. So common denominator of 18. So we're finding least common multiple, so 18 and 24 don't work. If I double 12, I get to 24. 24 and 18 still don't match up, so I'm going to double 18 and get 36. If I take 12 times 3, I get 36 as well. That's our common denominator. So 18 was times 2 to get 36. 2 times 7 is 14. 12 was times 3 to get 36. So 11 times 3 would be 33. Okay. So this is stuff that we may have to use in order to compare and order fractions. So we can look here and go, okay, well, which one's bigger, 1/3 or 1/9? Now, we should be able to go, okay, if I take something and break it into 3 parts, those should be bigger parts than if I take something and break it into 9 parts. But we can also find greatest common factor, not greatest common factor, but the least common denominator, which 3 can go into 9, so 3 times. So I would take this times 3 and get 3 9s. So now obviously it's clear, hey, this one's going to be bigger than what this one here is. But again, we can look at it as parts as well. If I'm 3 parts, they're going to be bigger parts versus if I broke it into 9 parts, those are going to be smaller. I still have one of each, so I have one bigger part versus one smaller part. So that one's a little easier to do that. We wouldn't necessarily have to find the equivalent fractions. But if we get to here, well, 9/10 and 5/11. A little bit harder, but still should be able to do it without, because here, 10 parts, we have 9 of them. Out of 11 parts, we have 5 of them. We have almost all of them here, where we're about half of them here. So obviously this one should be bigger. Even though this is 11, this is 10, we're still, overall, was what we're looking for. Now, we could have gone through and went, well, 110 is the closest denominator. So 10 times 11, this would make this 99 over 110. 10 times 11 would give us that, so 5 times 10 would be 50 over 110. Obviously, that one's bigger. But here, these are obvious enough. When we get, if it's really, really close, we may have to find those equivalent fractions in order to tell for sure. All right. Now, sometimes it's going to be just an order. So 7/10, 7/11, 7/9, 7/12. So here, the tops are all the same. So really, it's going to be the bottoms that are going to be what we're going to use to tell them apart. Now, the bigger the bottom is, really the smaller the overall fraction is. So if you look here, 7 over 9, we have 7 out of the 9. So that's most of them there. For 7 out of 10, well, now we have 3 of them we're short of, where here we're only 2 short of the whole thing. But since we're breaking up into 10, those are smaller parts, so we still have less there. This would be even less, and this would be even less. So if it's from least to greatest, the biggest number on the bottom then, if the tops are all the same, is going to be our smallest number. Because we have the most parts that we're breaking it up into, so they're going to be the smaller parts. And we only have 7 of those smaller parts. So the smallest number would be 7/12. 7/11 would be the next biggest. 7/10, and lastly 7/9. So, as you go as far as ordering, if the tops are all the same, you're looking at the bottom, the bigger the number, the smaller the fraction actually is. If the tops are all the same anyway. Now, these here, 11/12, 8/9, 4/5. These are all different tops. The bottoms are all different, but yet, is 11/12 bigger than 4/5? Is 8/9 bigger? We don't know. This one's really hard to do. So here might be a good one where we find common denominators. So between 12, 9, and 5, 12 and 9, the least common multiple between the two would be 36. 9 and 5, the least common denominator would be 45. So we're close, but not quite there. So another round, 12 and 5 would be 60. Can 9 go into 60? Well, no, it's close. Well, what about 120? Can 9 go into 120? Again, we're close, but actually no. And so this is going to get bigger and bigger and bigger. So maybe that's not the route we want to go. So we're still going to look at those denominators. How do those play a role in determining which one's bigger? Well, if I break this into 12 parts, I'm making them into smaller parts. But I'm only missing one part from that, so I'm only missing a small part from it. 9 parts, a little bigger parts. So I'm missing one, so I'm missing a little bit more than I would be from 11. Same thing here with 5. 5 parts are going to be much bigger parts. So if I'm missing one, I'm missing a much bigger part. So 4/5 is actually going to be the smallest one. 8/9 is going to be the next bigger one. And 11/12 is going to be the biggest. Because we're breaking it into 12 parts, we're breaking them into smaller parts, and we're missing just one of those. So we're missing a smaller part than we would here, and a smaller part than what we would here. So that's how I ordered them that way. Let me know if you have any questions. Otherwise, until next time, we'll talk to you later.